This video introduces sensitivity analysis in linear programming. Sensitivity analysis can be very useful in managerial applications. It kind of just asks the questions, hey, if something changes, if some of my parameters changes, whether it's the objective function or I get more resources so my constraints change, how does that impact my solution? And that can be useful for at least two reasons. The first reason is things in the environment change and you may or may not have time to update it. So you can go ahead and use a sensitivity analysis to try to figure out what's going on. The second big reason is often what you put down for parameters are just kind of guesses or estimates. And those estimates have error in them. And you're kind of wondering how much does that affect your final results and your final decision making. So let's just take a look at the series of videos we have. This is video number 4 in a sequence of 5. The last video was on Solver. So if you're not familiar with Solver, please go back to the previous video. We can show how you set that up. And we'll go through a little bit of a review of our half-baked bakery problem. So what we're trying to do is decide how many pounds of cookies to make, how many pounds of cakes to bake, and we would like to maximize the profits. Each pound of cookies contributes 20 cents. Each pound of cake contributes 30 cents. But we have constraints. Our bakery's only so big. We have 3 different operations. We have a mixing operation, baking operation, icing operations, and we have capacity constraints for all 3 of those. There's a total of 210 hours of mixing time, a total of 250 hours of baking time that we could use. We don't have to use it all. And 80 hours of icing time. And we only ice cakes and we don't ice cookies. Now the coefficients on my X and Y tells me how much of those constraints do each pound of cookies or cake consume. So for mixing, it's 0.3 hours for every pound of cookies and 0.3 hours for every pound of cake. For baking cakes, a pound of cake consumes more baking time than a pound of cookies, right? So 0.25 for cookies and 0.5 for cakes. And we're only icing cakes, and each pound of cake consumes 0.2 hours. Okay, so that's the basic setup. And last time, well, actually 2 videos ago, we were looking at the graphical solution, and I just plotted out the cookies versus cake space, and here's profit on top, right? And our constraints on our gives us a feasible region, right? So we have a constraint on mixing, which is this one, I believe. No, I'm sorry. The constraint on mixing is this segment, on baking is this segment, and icing. And the shaded area gives us what we can actually do. And the boundary line is the efficient frontier. And we set this up in Solver and said click, and we came up with 400 pounds of cookies and 300 pounds of cake for a daily profit at $170. Okay. Now, in the sensitivity report, what we're going to do is say, hey, what happens if I change my coefficient, my margins, a little bit for cookies and cake? So let's say instead of 0.2, what happens if it's 0.25? Instead of 0.3, what happens if it's 0.28? Okay. In reality. And how does that change the solution? And then we'll also look at, well, what happens if we get more resources? What happens if instead of 210 hours of mixing time, I have 220 hours of mixing time? Okay. And then we'll just run through that with the sensitivity report. So this is the graphical image of the solution, and we'll be using this when we go to shadow prices. But you have the efficient frontier, and your solution will be along the efficient frontier somewhere, most typically at a corner point where you have these at least 2 constraints meeting. And so at $170, this is the profit line, the ISO profit line for $170. And the solution occurs right where the ISO profit line just barely touches, kisses the efficient frontier, or is tangential to the efficient frontier. That's the optimum. If we did z is equal to 100, we can do all those combinations of cookies and cakes to make $100 worth of profit. we're within the feasible region, but we're not getting as much money as possible. On the other hand, if we got very ambitious, got a little bit greedy and say, hey, we'd like to make $250, well, not so good because we can't actually do it's not feasible. It'd be an infeasible solution. Okay, nice to have all that extra money, but guess what? Can't do it. And so this is the sweet spot. You can do it, and it makes as much as possible. Okay, so let's go ahead and take a look at the sensitivity report. In Solver, it comes into two pieces. One is called the variable cells, okay? And that has to do with how much you can change each of these particular coefficients. I'm sorry, here's my coefficient. These are the final values. Here's my objective coefficient. How much can I change these objective coefficients without changing the final value? And so we're going to first deal with the variable cells. That's actually the objective function, right? If I was writing the program, I'd call it objective function instead of variable cells. And down here's the constraints, and we'll talk about that in a few minutes. Okay. So just look at these coefficients. If you just focus in on cookies, right, we could change the coefficient from cookies from 0.2 all the way up to 0.3, right? 0.2 plus 0.1, and we'd still have the same final value for 400 and 300. It wouldn't change what the optimal solution is. And the same thing if you decreased it. We could take 0.2 minus 0.05, we could decrease it by a nickel, and it wouldn't change these two coefficients. Same thing for the coefficient for cake. Coefficient for cake is 300. We could move it up to 30 cents. We could move it up to 40 cents, increase it by a dime, and we'd still have 400 and 300. And same thing for decreasing it. Now, one key caveat, though, is we can only change one at a time. If you said to me, hey, what would happen if instead of 0.2, we have 0.25, and instead of 0.3, we have 0.25? I'd say, I don't know. Based on this output, I could not tell you what's going on. So just to give you a little bit of sense about that, I have a couple interactive Excel worksheets, and let me see if I can get out of here. And slideshow, okay. Let me move it away. Again, this is my graph we've seen before. This is the cookie space, and this is the cake space. And I just want to show you what happens as you change your coefficients. So here's my profit function, 0.2 and 0.3. And let's say I increased my coefficient for cake. Cake is 0.3. And so I just increase it up to 0.35. And you can see that this is starting to tilt, right? So this flat surface tilts as I change my coefficients. Same thing if I change my cookies. Right? You can see this starting to tilt, get steeper, more or less steep as you change these things around. Okay. Now, obviously, someone has too much time on their hand during COVID to make up such a spreadsheet. But the key fact is as you change those coefficients, you get a tilt to it. Now, if I go, instead of a surface plot, if I look at a contour plot, right, this is the contour plot, 0.2 and 0.3. Should make it a little bit bigger. Oops, a little bit too big. Oh, well. As I change the coefficients, you'll notice that the contour lines, the slope of the contour lines changing, right? And that's key in understanding what those allowable increases and decreases are doing to you. And so let me just amuse myself a little bit longer. You can see that those contour lines change as you change those different slopes. Okay, great fun. So let's take a look at the cake coefficient, just specialize it in, right? And so this is a plot you've seen a lot. So we have the feasible region because we have the mixing constraint is in blue, the baking's in orange, and icing is in green, like that icing. And so the feasible region is down here, beautiful. And then in our isoprofit line, My profit function is 0.2x plus 0.3y. Right. And so we're making $170, and it's right there at 400 and 300. Now, what happens as I change either the coefficient for x or the coefficient for y? I'm just going to focus on the coefficient for y. Those lines tip, okay? But sort of like the fulcrum for the optimal line is right here at 300 and 400. So if I just change it a little bit, I have some room to move it up and down. So let me just move right? I can teeter-totter this back and forth, and I'll still be at the same solution. Okay, it's just like a little teeter-totter. Okay, but if I 0.32, still at the same solution, 0.34, 0.36. Now notice the profit's changing though, right? So I still have the same 400 and 300, but if you look at the profit down here, it's 188, and as I change it, the profit is changing. 0.34. Now the key value is 0.4. What happens when I get up to 0.4? 0.36, 0.38, I'm at $194, and now I'm at 0.4. Now the ISO profit line, I'm making $200. A solution would be 400 and 300, but I'm actually picking up any of the solutions along here. And for business people, that's a good thing, right? If you're a mathematician or an engineer type person, you might say, hey, I want one solution. I don't like it when I have multiple solutions. But often as a business manager, you have a lot of things going on other than the amount of cookies and cakes. So this gives you some freedom to use some judgment and pick a value that works better for what you're doing at that particular time. Because there might be things in the model that you're not, things going on at your bakery that's not in the model. And so you like that flexibility. So for business people, having multiple solutions is actually a good thing, or can be a good thing. But now what happens if I bust that up above 0.4, right? The allowable increase was only a dime, 10 cents. So going 0.3 to 0.4 is fine. But once I go above it, can you guess what's going to happen? You start to pick up a different corner. Okay, so my profit's still going up, but instead of doing 400 pounds of cookies and 300 pounds of cake, I switched to 200. Okay, so as my coefficient for cake increases, each additional cake is more valuable to me, and so I want to start to make more cake. Okay, but notice that the icing constraint is going to be binding, right? Because I'm going to ice all the cake. So that's always going to be binding in this particular solution. So I'm making more and more money, right? But now I'm at a different solution point at 200 and 400. Okay. And we can go up farther. Okay, to 0.7. So I'm making a lot of money on cake now. Now, if I bring it back down, we can see what happens if that coefficient for cake gets smaller and smaller. Okay, we go back to original solution of 400 and 300. It keeps tilting. And yeah, if the contribution for cake gets small enough, right? I'm saying, hey, cake is not so good for us. Profits are going down, but I have the same solution at 200, 400. Now remember, the original coefficient was 0.3 and the allowable decrease was 10 cents, 0.1, 0.1. So I can only go down to 0.2 and still have the 400 and 300 pound solution hold. Once I go down below that, what's going to happen? Yeah. That's right. You're going to pick up saying, hey, just do cookies. Okay. So if the coefficient for cake gets too low, that means cake is not very attractive anymore. Cookies, relatively speaking, are more attractive, right? You want to do a ratio kind of thing here. You stop making cake because cake, first of all, you have to ice cake, and that's expensive. And secondly, cakes consume more oven time, and oven time's expensive. So yeah, just make cookies, and that's what we have. And so even though as we shrink down the coefficient for cake, we just end up with 700 pounds of cookies and 0 pounds of cake. Okay, so we go from being a diversified bakery to a specialist bakery that only makes cookies. I'd be fine with that. I do like cookies, so my life would be all right. And there you go. All right, so that's the variable cell. Let me go back to the PowerPoint presentation. I should probably and sorry, I have two monitors. Gotta switch over. There it goes. Okay. And that's what that was the adjustable cells up here, or variable cells. Okay. And the other part is having to do with the constraint. And just to orient yourself with the constraint part, you have the three constraints: mixing, baking, and icing. This is the final amount you use, 210. This is what you had. So mixing is binding. Baking, we have 250 hours of oven time. We used all 250, so that's binding. Icing, we have a total of 80 hours of icing. We only use 60, so this is not binding. And we have a slack of 20. 80 minus 60 gives me a slack of 20. Okay. Now, the really important concept here, and it's used even when people don't have a linear programming problem, is known as shadow price. Okay. And the shadow price tells you, like, hey, if I could increase mixing by 1 hour, right? If I add an additional hour of mixing time, go from 210 to 211, how will my optimal profits change? How much more money will I be making? So if I could get myself an additional hour of mixing time, right? Hire another baker to sit there and mix the bowl up, I'll be making 33 cents. Okay. Same thing here with baking time. If I could get myself an additional hour baking, right, from 250 up to 251, I'd be making an additional 40 cents or 0.4, which is good. And so that's very useful because it helps you do some decision making, right? Because if you say, well, these two constraints are binding, right? I'm capacity constraint. I don't have enough mixing. I don't have enough baking. If I was going to increase my capacity, where should I do it? And what would be the effect of doing it? And you say, okay, so baking is more beneficial, right? If I could get an additional hour of oven time, that's more beneficial to me than getting an additional hour of mixing time. Okay. So this is hugely important. Now, of course, you want to know what the cost is. How much will that additional hour of mixing time cost you, right? You have to buy another mixer or what? Or how much additional time would that oven time cost? Okay. So that's what these things are. Now you go down to icing, and you notice that shadow price for icing is 0. You got to think for a minute or two, why? Why would the shadow price be 0? That means if I add an additional hour of icing, take it from 80 up to 81, I have no benefit. 0. Doesn't do anything for me. And the reason why it's the shadow price is 0 here is because icing is not binding. I'm already slack. I have 20 extra hours every day anyway. So adding an additional hour doesn't help me out. Okay. Now, a little bit more finer detail is this allowable increase and allowable decrease. And it kind of acts just like the ones above, only now you're saying, okay, I have this constraint of $210. I have a shadow price. The shadow price is just for adding one additional hour, right? Or if you say, hey, if I take an hour off, how much would the profit go down by? If you went from 210 hours minus 1 down to 209, you would lose 33 cents. But this allowable increase and allowable decrease tells me by how much I could go up in my constraint or down in my constraint and still have this hold. For example, if I add 10 more hours of mixing, that's within my allowable increase of 90 hours. Okay. And so the net benefit would be 10 times 0.333, or move the decimal over, $3.33, right? So 10 hours would be worth $3.33. Okay. What if I added 100 additional hours? I'd say no, don't know, because you're beyond the allowable increase. Okay. Okay. Actually, what happens if I added an additional 100 hours, then mixing will become slack. Okay. So if I go above 90, then this will become slack. Okay. And I'd have a different solution. Okay. So it just tells me how much I could increase or decrease my constraint and still apply the shadow price to it. Okay. All right. So let me go to a graph of that. Got some graphs. And here's the sensitivity. Shadow price. So we're just taking a look at mixing. Okay. So mixing is 0.3x plus 0.3y, and it's this blue line. My profit's at 170. Okay. Now, what I'm going to do is I'm going to vary the 210. And if I increase this by, again, $1, then the profit goes up by 0.333, the shadow price. Okay. So let's just go ahead and click this, and I'm going to increase it by 5. And now I've gone up to 172. So I increased it by 5. So if you go 5 times the shadow price, which is 0.333, I get additional 1.66, right? So I did rounding here. I didn't want a bunch of decimals, but that's how that profit changes. And so you can see as I keep increasing my amount of mixing time I have, 220, 225. Okay. What happens? Well, this mixing constraint gets pushed up. Okay. So I'm increasing my feasible region. Now my profit plane has the same kind of line, but because the mixing constraint is being pushed up, I get a bigger and bigger feasible region, so I can use a higher and higher ISO profit line. And so instead of making $170, now I'm making $177. And I can keep pushing that up, 35, 40, 240, 245, 250, 255, 260, 65, 70, 75. Okay, I'm going to get close to 290 and start to think about what's going to happen if this bound on my capacity gets up to 290, then 300, right? I can only go up by 90, 280, 290, 85, 90, 95, 300. Okay, so 210 plus 90 is 300. And now the mixing is no longer binding. It's totally off the page. Okay, and so it is no longer a binding constraint. What is binding is just my baking. And if I take it down, we can see what happens as we take it down. The original formulation is 210. Okay, and as this bound, if I take resources away, right, this would be a minus 1.665. I'm losing down to 168. What was that? 210? 210 was 170. Now it's gone down. Okay. Again, I round that. And if I keep getting it smaller and smaller and smaller and smaller and smaller, oh, okay, that's where I have to kind of stop. If I go down below that, this picture kind of falls to pieces a little bit. But that's sort of like the range of values that the shadow price is operating in. All right. Okay. So again, the way you would use that shadow price is, let's say you added, the shadow price was 0.333 for mixing. And if I added 10 hours of mixing time, then my shadow price I'm sorry, my increase in profit would be 10 times 0.33. Or if I had 20 hours, it would be that. If I took away 20 hours, it'd be a minus $6.66. Okay, so this is the shadow price, and this is the amount you would increase it by. Okay. All right. Okay, great. So let's go back to, I had fun making up those Excel spreadsheets. So much fun doing that kind of interactive stuff. Let's see, I guess I have to go back to presentation mode and display settings. Okay, there we go. So just as a review, the shadow price is really used quite a bit within business, right? You want to always be asking, hey, if we did get more capacity, right? Remember, you always have constraints. Constraints are like people constraints, capital constraint, equipment constraints, intellectual property, brand constraints. How would you say my brand's constrained? You have these kinds of constraints, and you should be asking, well, hey, if we did change those, yeah, would we be better off, and by how much? Okay, and that's exactly what these shadow prices are getting at. Okay, now again, if something is slack, then the shadow price is 0, and geez, there's no reason to, if you have slack, there's no reason to increase it. Now we could decrease it, right? I could say, hey, I have a slack of 20. If I got rid of my slack, decrease it by 20, instead of saying 80, bring it down to 60, then this becomes, icing starts to become binding. If I go less than 20, go from 80 down to, let's say 50, right? Decrease it by 30, then icing would then become binding, and then mixing would become slack, right? So if you change these by too much, then you're kind of like your shape, your feasible region changes by too much, and you just have to rerun solver to get the answer out. Okay, great. Thanks very much. This sensitivity analysis can be very useful to you as a manager. Okay? It's just not some weird remote thing that only techie persons do, but it can be extremely useful in running your operations. Okay. And so, it helps you understand the problem a little bit more. Okay. We did two things: allowable increase and decrease for the objective function. How much can you change the contribution and still have the same result coming in? And then also the shadow price. If you start adding resources, how does that change your optimal solution? I'm sorry, your value for your objective function. Okay. All right, great. I hope you enjoyed this video. I hope you got something out of it. The next video is going to be putting fixed cost into the profit function. So right now, the profit function only has a variable cost. So as we vary our production, pounds of cookies and cakes we make, the profit function changes. That's called a variable cost. I can come in every day and I can change the amount of cookies and cakes if I had to. Fixed costs have to do with something like, hey, if we don't make any cookies, we don't have any setup time for cookies, we don't have a fixed cost for cookies. But if we do make cookies, we have to have some setup time for cookies. We get a fixed cost, and that fixed cost is there whether I make 1 pound of cookie or 1,000 pounds of cookies. Okay, and so to bring those fixed costs into the profit function, I need to do binary variables that take the values of 0 and 1. Now, in one sense, that's my kind of math. 0 and 1 is really easy to do math with. Unfortunately, in optimization, it makes the problem extremely hard. So if you ever take a course on optimization in a school of engineering school like operations management or industrial engineering, you will have these really big fat textbooks. And they go through the algorithms, and the algorithms are very tough for things like mixed programming or what they call integer programming. But we're not going to worry about that. We're going to trust in Solver. Okay. And Solver can do it with these little tiny problems. Solver will break. The free version of Solver will break if you try to do with industrial size. Now, the really cute thing is they have linkage constraints. Okay. And the next video goes through how you set that up with linkage constraints to make it work. So again, if you like these videos, please give me a thumb up, and, you know, in the comments, let me know. And if you have some other topics you'd like to see, you know, I'll take it under consideration, but please keep in touch. I hope to see you in the next video. So long.